Here we go. Number 1 says solve using your graphing calculator. Now, just a quick reminder, even if they hadn't said using my graphing calculator, how would I know? Well, on the test, this will be a multiple choice question, and Amanda, the answers will all be decimals. Also, though, I got a sine and I got a x not inside a trig function. You can't solve that without calculus. And circle. So how am I going to graph this? Well, I'm going to graph, well, first of all, I'm going to make sure I'm in radians, which I'm not. Remember those of you that are in Physics 12 or Physics 11 especially, you're often flip-flopping. Graph y1 as sine 2x. Graph y2 is 2 over x. They did give me a domain, so I know my x-min is 0 and my x-max is 2 pi. If they didn't give me a domain, Holly, I'd probably go from negative 6 pi to positive 6 pi is usually, and then probably I'll have to zoom in. Oh, wait a minute, I don't need to go way out that far. I'll go back and quickly change my windows and move around a little bit, but it can be done. Scale, when in doubt, I go pi by 6. That's my 30 degrees. Y-min. What's the amplitude of this trig function? What's in front there right now, Jess? Once, I think the amplitude of this side is -1 positive. It's going to get -1 positive. This one I'm not so sure. You know what? I'm going to go -3 to 3. I may be able to zoom in. I may have to zoom out. I don't know. But that's how I kind of guess these, Nathaniel. I use a bit of intelligence and just kind of a gut instinct, and then I move around. Let's see if I guessed right for a nice graph. Well, there's the sine 2x. That looks good. Oh. Okay. First of all, how many solutions are there, Carson? There got to be 2. Let's go find them. Remember I said if it's multiple choice, often you'll be able to cross out some answers already because there might be one that has 3 solutions, or there might be one that has a solution if this whole thing is 2 pi, less than pi, and there's no solution, then you can cross it out without even trying to do it. Anyways, let's find the roots. Second function, calculate, intersection, first curve, second curve, yes. 3 decimal places, so 3.451. That gets you a half mark. And 4.481, half mark. Hopefully you can do it a lot quicker than it takes me to explain how to do it. For next questions, you must show work, solve the following algebraically. I notice there is a period change. I see that there is something in front of the x. So here's what I'm going to do. Temporarily, I'm going to replace that 3x with an a. I always do that first. And I do one more thing. There is, Holly, a period change. This is important. Right away, I also write down my period, which is going to be 2 pi over b, which in this case is a 3. And I'm going to solve this. And then, Nathaniel, I'll unsubstitute later. This is called, by the way, this is called using a substitution method to make an equation look nicer. You don't have to. I've had kids that just kept the 3x there and tracked it all the way through. Fine, but this is a little easier. Cast rule, Holly. Sine is negative here and here. Do I have a triangle with a √3 and a 2 in it, Holly? Oh, then I can use an exact value. Otherwise, I'd go second function sine of whatever they gave me, and I'd get a decimal, and I could still get it as decimals. But in this case, I'm pretty sure it's the 1, 2, √3 triangle, where this angle up here has a sine of √3 over 2. How big is this angle up here? Pi by 6 or pi by 3? Okay, this is pi by 3, which means this is pi by 3, and this is pi by 3. He says writing really, really small so that nobody at the back of the room can read it. I think what I'm saying, though, is this. My first a value is 4 pi by 3. My second a value is 5 pi by 3. Except that's not what they asked me to find. They didn't ask me to find a, Nicole. What variable did they want me to solve for? They didn't ask me to find a, Nicole. What variable did they want me to solve for? X. Yes, yes, yes. Okay, if I know a, which I do, how can I find x? Or if you look at my little substitution equation that I jotted down here, how would I get the x by itself? Divide by 3. You know what? My first x value is going to be this divided by an extra 3. It's going to be a 4, a pi, but a 9 down there. My second x value would be this divided by 3. It's going to be 5 pi by 9. Now that's the first two answers between 0 and 2 pi, but Matthias, there may be more. There are more. How can I find the next one? Well, it's going to be one period further than this. Except, let's get clever. Matthias, what do I have on the bottom here? You're not saying no to me. I should have done that to Leah. Oh, that would have been great. You can say no, 9, no, 9, no. Ah, okay, fine. What do I have on the bottom here, Matthias? You know what? Why don't I make this over 9 times... why don't I make my period 6 pi over 9, which is 2 pi over 3, but that lets me do this in my head, because now I can tell you there's going to be a third x value. It's going to be this plus the period, 10 pi by 9. Right? There's going to be a fourth x value. It's going to be this plus the period, 11 pi by 9. Is there a fifth x value? I don't know. Let's see. If there is a fifth x value, it's going to be this plus the period, 10 pi by 9, 6 pi by 9. That's 16 pi by 9. Is that still less than 2 pi? Yeah, actually, 2 pi would be 18 pi by 9. I'll quit when I get there. Is there a sixth value? Might be. Let's see. This, yeah, 17 pi by 9. Yep, 17 pi by 9. Is there a seventh value? Well, if I add 6 pi by 9, the period, to this one, you know what, Katie, I get 25 pi. You know what? I'm out of the domain. 21 pi by 9. No, 22 pi by 9. I'm still out of the domain. You know what? There is 1, 2, 3, 4, 5, 6 answers. How would I mark this? Well, it's 4 marks. First of all, if you got all 6, whoops, if you got all 6, you would get 4 out of 4. I would probably do something like this. If I saw that substitution, that would get you a half mark. If I saw that you had written down the period somewhere, I would say, aha, that gets you a half mark. If you found both of these, that would get you a half mark each. So if you found A, then I would give you a half mark for the first answer, x1, a half mark for the second answer, x2. That's 3 marks. Then I would probably say each one of these that you're missing will cost you a half mark. So these grand total would be worth 1 mark, but any ones that you were missing would cost you a half mark from that one. Something like that. Okay, it's going to be one of these on your test, on the written. In fact, I'll even say you can even write this down if you want. I think it's question 1. I have to go double check my test, but I'm pretty sure it was always the first written question was a period change. Oh, give the general solution. Now, all I'm going to do is I'm going to list the first 2 primary or principal roots, which were 4 pi by 9 and 5 pi by 9. And to both of those, I'm going to add multiples of the period. What was the period? 2 pi by 3. And to show that I'm adding multiples, I put an n there, and then I mention, oh, n is an integer. You could have put 6 pi by 9 here, Carson, if you didn't bother reading. That's fine, but okay. Example 3. Solve that. What kind of an equation is it? It's quadratic. How do I know? It's got a squared. So, first thing I got to do is make it equal to 0. And remember, what I'm really seeing is this. 2a squared plus 7a plus 3 equals 0. Except instead of an a, there's a cos. But I'll factor this, but wherever there's an a, I'll put a cos. How's this factor? Let's see. Going to be a 2a, not an a, Mr. Dueck, 2 cos x cos x. I think it ends up being this, plus 3 plus 1. Is that right? Don't ask me how I did that, by the way. Jessica, I've done so many of these, my brain goes blank and the answer pops in. Somehow there's a little factoring circuit. But I did show you the grouping, not groping Ryan, grouping method, yes? What are my roots? Well, I get this. Cos x equals negative a half. Change the sign and divide by the coefficient. And I get cos x equals negative 3. Nicole, I'm interested in this one here. Why is this one really easy to do? How high does cosine get? What's the amplitude of cosine? What's the highest it gets? 1. What's the lowest it gets? This is saying, when does cosine get negative 3 high? Or negative 3 low? You know what? Never. Now I'm going to be fussy here. If you didn't cross this out, I won't give you a half mark. It'll cost you a half mark. Because every year, Matthias, I get kids who write this and they try and solve it and they can't and they freeze and they just, I don't know, I'm just stupid, I don't know what to do. They haven't actually realized there is no solution. They just think they can't find the solution. So to show me that, Holly, you have recognized, hey, Dueck, there is no solution to that, cross it out, write no solution, something, indicate it. Over here, now, by the way, I'm running out of room, so I'm going to cleverly move this a little higher. Do that. Cosine. C-A-S-T. Cosine is negative there and there. Do I have a triangle with a 1 and a 2 in it? Why, yes, I do. It's the 1, 2, root 3 triangle, where this angle here has a cosine of 1/2. Hey, my reference angle is pi by 3, which means x1 equals 2 pi by 3, and x2 equals 4 pi by 3. Is that right? How would I end up marking this? Well, for what it's worth, I would probably give you 1 mark for that, 1 mark for that, 1 mark for that, a half mark for the reference angle, and a half mark for crossing out the no solution over there. Amanda, you'll notice, you know what you don't get marks for? The actual factoring process, because they feel that that's math 10 and they're not going to give you marks for doing math 10. In other words, suck it up, you better learn how to factor. Because now it's like an expected skill. Number 4, solve this puppy. What kind of an equation is it? Quadratic. How do I know? It's got a square. Okay. Blah, 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 blah. How's this one going to factor? You know what? I think it's going to factor into 3 sine x minus 4 and plus 2. Is that right? Yeah? Again, I mean, I have no idea how to do that. It's a little bizarre. Oh, what am I going to get for roots? I'm going to get this. Sine x equals negative 2 over 3. And I'm going to get sine x equals positive 4 over 3. Oh, ooh, Cassandra, pay attention here. I don't care about the hallway. Not worth it. Pay attention here. You know what? Look. Why? What's the highest sine's going to get? What is the highest sine's going to get? 1. Will sine ever touch 4/3 high? Will sine x ever cross 4/3? Nope. No solution. Over here, do I have a triangle with a 2 and a 3 in it? No, I got a triangle with a 2 and a root 3, but not a 2 and a 3. You know what, Ryan? This is not going to be a special triangle question. I'm still going to use the cast rule. Sine is negative there and there, but I'm going to find the reference angle by taking the inverse sine of positive 2/3, not negative 2/3. I use the negative to figure out where I am on the unit circle. Inverse sine of 2/3. My reference angle is, well, they said to go to 3 decimal places, so 0.730, I guess. Which means that this angle right here and this angle right here are both 0.730. I think my first x value is going to be pi plus 0.730. $3.872, and my second x value is going to be 2 pi minus 0.730. $5.553. Is that right? People nodding? Yeah, no? Am I wrong? No, I'm good. In terms of marks, I would probably do something like this. You'd get a half mark for crossing out the no solution. You would get a half mark for getting that factor. You would get a half mark for the reference angle. You would get 1 mark for that, 1 mark for that, and I'd probably give you a half mark for getting the correct quadrants. Is that 2? 1, 2, yeah, something like that. Last one. Solve this. Okay. Tan x numbers multiply to -3 and add to -2. How about -3 plus 1? Yeah? You're going to get this. Now, Holly, what this here is saying is, when is tan x 3 high? Every year I have kids want to do that. Remember, tangent's the ugly cousin. What did tangent look like? What was its range? Its range was all reals. In fact, one year on the provincial, they gave a question, and when you factored it, you ended up with a 12 there. And about 80% of the kids went, oh, there's no way it gets that high. Yeah, actually it gets to infinity high. Tangent will get 12 high and -12. In fact, it'll get -1,000,000 high and +1,000,000 high. It's got a range of all reals. It's the ugly cousin. So you can't actually cross out. Whoop. Come back. This will have an answer. What will the answer to this factor be? Well, I would write the cast rule. Tangent is positive here and here. I would say to myself, do I have a triangle with a 3 and a 1 in it? No. Then I would find the reference angle. The reference angle is going to be the inverse tan of 3. The reference angle ends up being 1.250. Which means that that angle there and that angle there are both 1.250. I think it means my first x value is just 1.250, and my second x value is going to be pi plus 1.250. How about 4.391? Yep. Here. Roxanne, what I really see here is that. Now, I'm not going to write it, but I see a 1 over 1, because I can say to myself, do I have a triangle with a 1 and another 1 in it? Oh, yeah, this is the 1, 1, root 2 triangle, which we hardly ever use, but oh, yeah. This is going to be, again, the cast rule. C-A-S-T. Tangent is negative here and here. This is going to be the 1, 1, root 2 triangle, where this angle has a tangent of 1 over 1, where this angle is pi by 4, which means that angle is pi by 4, and that angle is pi by 4. It means my third x value is going to be 3 pi by 4, and my fourth x value is going to be 7 pi by 4. Amanda, how many marks was this question worth? How many answers did you find? Would 1 mark per answer make sense? Sure. On the test, actually, I give a half mark for each. I give some mark for the work, but here, 1 mark per answer. Oh, wants the general solution. Okay. The general solution is write your principal roots and then, Sabrina, add the period. Careful, ugly cousin. What's the period of tangent? Not 2 pi. What's the period of tangent? Okay, so it's going to be where n is integer. Mr. Dueck, yeah, Nathaniel, why didn't you write x2 right there? You could, it's not wrong, but believe it or not, if you add pi to 1.25, you know what you get? 4.391. It's redundant. Oh, and the reason I didn't bother writing the fourth x value, you could have written 7 pi by 4 plus multiples of pi, except if you add pi, 4 pi by 4, to 3 pi by 4, you know what you get, Nathaniel? So I didn't bother writing them. They're redundant. I wouldn't take marks off if you did, but they're redundant. I'd probably go half mark for that for you, 1 mark. Give yourself a score out of 19, and then be prepared for an identical quiz in about 10 minutes or so. I'm not going to collect this one. I will collect the next one. So last day we looked a little bit more at identities. Specifically, we did some practice, and then I introduced to you the concept, my last resort concept, what we called the conjugate. I gave you some questions to try from the workbook and some questions to try from the Great Big Identities Review. But if you can open your workbook, please, to page 46. Page 346. Any of these you want me to go over, now is your chance to ask. Yeah. 3B? Love to. Prove this. Okay. Suggestions, Amanda? Now, here's what I'm going to say, by the way. I will never leave these blank, ever. I got to try something. So let's walk through a mental checklist. What would I try first? Yeah, there's more than 2 trig functions. Let's rewrite everything in terms of sine and cos. So secant is 1 over cosine. So secant squared. This is going to be 1 over cos squared minus sine squared. Did I just write a fraction, Amanda? Say yes. Then I'm going to go like this, and I never want half and half. That's just dumb. Everything fraction or nothing fractions. And I'm going to write this as cos squared over 1 plus sine squared over cos squared. Now what? Which side looks uglier? I think, to me, the answer is they both kind of do, which suggests to me I'm probably going to do some work on either side. Is that all right? Factoring GC. Nah. You know what? I think my best bet right now is to try and write this as 1 fraction equals 1 fraction. To do that, since I'm subtracting, I'm going to need a common denominator. What's on the bottom of this fraction? What's on the bottom of this fraction? I think my common denominator is going to be cos squared. So I'm going to multiply the top and the bottom of this fraction by 1 by cos squared over cos squared. When I do that, I'll get 1 minus sine squared cos squared. So far, so good? I have no idea where I'm going, by the way, and I may end up in a dead end and have to backtrack. We'll see. Over here, I'll try the same thing. So my common denominator, I think, is going to be cos squared. So let's try going cos squared, eesh. You know what? I'm getting a cosine to the 4th right here. That makes me nervous. Having done a bunch of these, once in a while I'll get a cubed and a GCF will factor out and bring it back down to a squared. This 4th is making me nervous. Also, I don't see a GCF here or anything like that. I don't see a GCF here or anything like that. So Amanda, I think my current approach is wrong. No. Don't reach for the answer manual. I'm teaching how my brain works. I think my current approach is wrong. I don't think I want to rewrite these as a single fraction. So I'm going to do this. I'm going to do this. I'm going to do this. What was the first thing that we tried? You know what? I'm even going to abandon that. I'm going to completely cross out this first line. Okay. I'll show you why. I got to try something else. Now I'm going to start grasping at straws. You have your formula sheet? What is tan squared? From the top row, please. Not from, I know it's sine squared over cos squared, but there is another thing I have for tan squared. Do I not? It's not secant squared. There's a 1 in there somewhere, is there not? Okay, what is tan squared? Don't say you said secant squared. It's not secant squared. Read me the equation, kiddo. The whole equation. Okay, so what is tan squared? Secant squared what? What do I have over here? Oh. Let's try replacing this tan squared with... Now on the right-hand side, that's going to give me this. Is that okay? And then, you know what I would do just so I can see things better? What's in the front of this side here? What trig function do I have there? You know what? I'm going to rewrite this and just write the secant squared first. Plus, and then I have cos squared x minus 1. See that? See that? Do those match? That suggests to me that somehow cos squared x minus 1 is the same as a negative sine squared. Is it? Now go look at that first identity, the sine squared plus cos squared equals 1, and ask yourself, is negative sine squared, you have to rearrange it in your head a little bit, is negative sine squared the same as cos squared x minus 1? Is it? So if I know that oh yeah, because if I move this, that would become a minus. That would become, this is actually equal to negative sine squared. This is Turns out it was actually 3 lines. Not too bad, but I had to see that there was 2 Pythagorean identities. And you know what? I should have, because everything was a squared, I probably should have looked at that top line first. And I've just given myself another, I won't call it a rule, it's not a hint like the hints that I gave you, but maybe another approach is, hey, by the way, if everything's a squared, Dueck, before you change everything to sine and cosine, double check to make sure you can't do some substitutions from the top row. Now I know. Is that all right? Any others? Yeah. Okay. Where are my hints? Reread everything in terms of sine and cos? Maybe, but there's only 2 trig functions, and cotangent and tangent are very related. Yeah, I'm gonna hope maybe not. This might be a conjugate here, because there is a binomial denominator with no squares. You know what? Actually, I think I'm going to try rewriting everything in terms of sine and cos. This is why I said the other day, there's a science to these, there's an art to these. I just did some math in my head, trying to plug some stuff in, and I went, it's getting yucky. Let's try rewriting everything in terms of sine and cos. Now, on the right-hand side, first of all, there's going to be a negative. What's tangent in terms of sine and cosine? That's sine over cos. So what would 1 over tangent be? Cos over sine. And I'm going to suggest, Ashley, I'm done on the right-hand side. On the left-hand side is where I'm going to spend the rest of my time. The uglier side. Cotangent, that's cos over sine minus, and since I wrote a fraction on the top, I'll make the 1 a fraction as well. All over. Tangent is sine over cos, and since I made that a fraction, I'll make the 1 a fraction as well. Oh, I have a complex fraction. See it, see it, see it, see it, see it? Now my path is set. As soon as I have a complex fraction, what I'm going to do is I'm going to multiply the top and the bottom by the common denominator. I think sine cos. See it? I'm going to multiply the top by sine cos and the bottom by sine cos. But actually what I said is make everything 4-level fractions so you can clearly see where your top on the top and where your bottom on the top and where your top on the bottom and where your bottom on the bottom, where everything is. And it's going to go chunk, 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 chunk. So far so good? Okay. In this first one, a sine will cancel, yes? And I'll end up with a cos times cos, or just plain old cos squared. In this second, oh, and a minus sign. In this second term, nothing will cancel. So I'm just going to get sine cos. So far so good? In the bottom here, in the first term, a cos will cancel. I'll get a sine squared. In the second term, nothing will cancel. I'll get a sine cos. Ashley, don't write this down. Can I do this? Because can I cancel? What question do I ask myself right away instead? Have I factored? Have I factored? No, then don't you. Those are the ones that are going to be so tempting because you're going to be like, oh, a negative sine theta cos. Oh, you cancel this. I get cos squared over sine squared. That's not the cos you get. No. But I can factor. By the way, I'm going to run out of room here, so I'm going to go like that. I can factor this GCF out of the top.
Please excuse this interruption. We are missing 3 students for the first round of grade 10 interviews. Could Alexander Olasavich, Liam Godfrey, and Jacob Greeno please report to the library as soon as possible? Again, that's Alexander Olasavich, Liam Godfrey, and Jacob Greeno. Please report to the library.
GCF out of the second one. And I started to smile right about here, Ashley, because I said, what do I have on top right there? What do I have on top right there? What do I have on the bottom right there? What do I have on the bottom right there? Are these two brackets identical, though? Well, here the cosine is positive. Here the cosine is. Here the sine is negative. Here the sine is. They're not quite identical. Oh, but wait a minute. Look. What do I have right there? You know what? I shouldn't have factored out a positive cosine. You know what I should have factored out? A negative cosine. What would that do? That would make that negative, yes. And that positive, yes. And now are these two brackets identical? Can I cancel? Have I factored? And by the way, if you don't catch that, you would have noticed it on this line that they didn't quite match, and it's easy enough to put a negative there and just write them on in. So if you did, I actually saw that I was going to have to factor out a negative here already, but if you didn't see it, you would say, oh, how do I get that negative? Oh, I can actually factor out a negative if I want to. It's there. We just never think about it, but it's there. And final answer, negative cos. Oh, and then C says, state the restrictions. Okay. There's several restrictions here. First of all, tangent can't be 1, because if this works out to 1, I'll get 1 minus 1, which is 0. Can't divide by 0. But also, tangent has a little mini fraction in and of itself. It's sine over cosine. Cosine can't be 0, because I'd be dividing by 0 right here. Oh, but Jessica, cotangent. See cotangent? That's also a little mini fraction. Sine can't be 0. Hey, Mr. Dueck, can cotangent be 1? Yeah, I don't care if the top works out to 0. It's denominators. Little mini denominators can't be 0, and overall great big denominators can't be 0. Can't divide by 0. Now, if you look in the back, by the way, Nicole, I think what they actually then did is they found which theta makes 1. I think it's pi by 4. And they found which theta has a cosine of 0. I think it's pi by 2 and 3 pi by 2. And they found which theta has a sine of 0. I think it's 0 and pi. And they wrote those. I won't make you go that far. If I'm asking you for restrictions, I just want you to tell me the trig function restrictions, not bother solving the angles. I've tested you on can you solve an angle. Is that okay, Ashley? Yeah? It's clicking different points for different people. It'll click. Any others? For D. Yeah. Which is the uglier side? It's pretty obvious. Very quickly on the right side, I said, oh, 4 times secant squared. That's really a 4 on top and a cos squared on the bottom, because secant is 1 over cos, so secant squared is 1 over cos squared, and there's a 4 on the top. I did that, and then I forget it. How do I know to do that, Mr. Dueck? There's only exactly 2 trig functions, because I've done so many of these. How many fractions do I have here? How many fractions do I have here? Maybe rewrite it as a common denominator, 1 fraction. Now, what's my common denominator going to be? Well, believe it or not, it's going to be 1 minus sine theta, 1 plus sine theta. Is that okay? Now, right when I wrote that, I got my nerdy adrenaline rush, because you know what? If I FOIL this out, I'm going to get 1 minus sine squared, which is cos squared. So that told me I was on the right track. Oh, and I got a couple of 2's. I'm pretty sure I can get a 4 out of that somehow with a bit of magic. Let's see. Okay. In the first fraction, I have a 1 minus sine theta. To change it into a 1 minus sine, 1 plus sine, I would multiply the top by 1 plus sine and the bottom by 1 plus sine. I would get this 2, 1 plus sine. Is that okay? This plus sign would drop down. To change the second fraction to get a common denominator, there's already a 1 plus sine theta. I would multiply the top by 1 minus sine theta and 1 minus sine theta. And I'll get a 2 and a 1 minus sine theta. So far, so good? Now what? Well, let's FOIL out the denominator. It's going to be 1 minus sine squared. It's difference of squares. You get a 1 and then a minus sign and a plus sign, which cancel, and then a minus sine squared. Let's multiply the top out too. I'll get a 2 and a plus 2 sign and a positive 2 and a minus 2. Oh! What does the top actually simplify to? Let's do numbers first. I got a 2 plus a 2. Ooh, and what's positive 2 sine minus 2 sine? They can't. Are you telling me the top works out to just plain old 4? Which is kind of what I was hoping for. No pun intended. Yeah, kind of what I was hoping for. Ha ha ha, Mr. Dueck. Which would suggest to me, Amanda, even if I'd forgotten that the bottom there probably is supposed to work out to cos squared, so I go trundling off to my formula sheet and I would say, oh yeah, sine squared plus cos squared equals 1. That would mean that cos squared equals 1 minus sine squared. There we go. Yay! Amanda's fighting hard not to yawn. Okay. Any more? Okay. It is finally, at long last, time for my Trig comics. Read and see if you can figure this one out. It says, Alex was having second thoughts. Here's Alex. Hey, son. Here's his son. Here's the mom. Here's the mailman. Think about it. I love this because it's actually a joke based on a trig identity. Amanda, I don't get it. Explain. What? Sine squared plus what equals 1? Sine squared plus cos squared equals 1. Alex was having second thoughts. Hey. Mathematicians should not teach gymnastics. Arg, I said a 3 pi right twist, followed by a somersault, and end with a 3 pi by 2 left twist. Nice tan. Tan X's. Tan X. Yeah. Okay. This is about 2 years old, and apparently it has actually changed the chain. Dear Subway Incorporated, your cheese slices are shaped like this. Figure 1, isosceles cheese. This is great because it allows you to tessellate the cheese across the sandwich like this. Beautiful coverage. Figure 2, life worth living. However, you guys never do this. Instead, you always arrange your cheese like this. Unnecessary dairy overlap. Figure 3, soul-crushing disappointment. Please stop doing it like that. Thank you, Drumo. I've been told in Australia, and I've been told apparently in the interior they have stopped doing it that way, but I know the one in East Maple Ridge still has unnecessary dairy overlap. Oh, terrible. What's for lunch today? Let's see, there's chicken pot pie, pizza pie, cherry pie, and apple pie. Basically pie, 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 and more pie. You do this just to torment those of us with our trig midterm today, don't you? You know, you're the 3.14159th person to ask me that. I think they finally found a way to make us study. Today's special, 1 over 256 to the 1/4 powder to the 1/4 pound bird. Oh, does that work out to a half pound or a 1/4 pound? I have to think about it. Avec pomfrite and a 473.176 cc drink. Price, oh, $3.99, because that would move to the front and the LNB is 1. We also have pi by 3 radians pizza slices, which would be what fraction of a pizza? If I cut a pizza into pi by 3 radian slices, how many pieces are there? 6. Yeah. What are you geeks doing? We're having a math showdown. We challenge each other to recite pi backwards. Whoever goes first loses. No, I think whoever enters this room loses. I am so infinitely not close to going. Ha! I'm infinitely +1 not close. Okay. You have 10 minutes left, people. You can do this, Peter. Think. Hey, he's writing a trig test. Let's try not to drill on our test, Mr. Fox. Trig class should not be the period before lunch. Tyson brought us Timbits today, so we don't have that problem. So, the father is taking the young nerdy son out golfing. The young nerdy son Jason says, "Man, it's like they want this game to be one big headache." Father says, "Oh, you've noticed. That's the whole point behind sand traps and water hazards and undulating greens. Golf is meant to be a thinking man's sport." I'm talking about their use of yardage and degrees of loft. I could compute all my shots in my head had they instead used meters and radians. Fortunately, I memorized the conversion formula. You know it's possible to be thinking a tad too much. Which I now have on a t-shirt, yes? Hell's Angles. Los Alamos, where they built the atom bomb, 1945. We have a decision. If we've done our math right, this test will unleash heaven's fire and make us as gods. But it's possible we made a mistake and the heat will ignite the atmosphere, destroying the planet in a cleansing conflagration. Wow. Question. Just to double check, although I'm 99% sure. Is it Sokotoa or Kosatoa? Oh, for the love of... Can someone redo Steve's work? I don't want to do tests anymore. Can you name this famous city? Manhattan. Manhattan. Next. Mel Gibson stars as a Pennsylvania farmer who discovers a mysterious crop circle in his cornfield. Will his knowledge of basic trigonometry be enough to determine the y-coordinates of points on the circumference? Find out as we present the television debut of M. Night Shyamalan's Signs. Signs. This new math channel rules. Did you watch Charlie's Angles last night? Okay, tough audience. I did that one already. 8/10 over the square root of 2. Hey baby, what's your sign? Oh, come on, that's a great math pickup line, huh? Hey, huh? Yep. I've been tempted. But I think they actually added that by hand, because that doesn't, I don't know if you can do equal signs. What famous movie is this? Sin City. Yes. Sign City. But there you go. You got that right away. I'm impressed. Okay. It's right, isn't it? To two decimal places. I'm almost tempted to start writing mathematical constants as my tips. I think that would be interesting. Happy Pi Day, belated Pi Day, but Pi Day was during spring break. I think I sent you all an email. We're calling it pumpkin pie. I'll put this on the end until we buy more. Now, which one didn't work there? That one right there. Oh, I think I already got that one anyways. I think. So I could... Is the one before the receipt? Oh, Noah. Okay. Open with. Let's try that. Sure. Can I make it bigger? I don't think I can. Here's Noah. There's the animals. God's saying, okay, let's run through this one more time. Noah's Ark. Noah's Ark. Okay, tough audience. Yeah. I think those are all my math comics. I'm deliberately going to